So now talking about Cartesian product. So what do we mean by Cartesian product? First of all, we represent it by A cross B. This means that every element of A has been mapped to each and every element of B. So let me explain it to you with the help of a Venn diagram. So let's say if this is my set A. Now let me assume that A set has elements 1, 2, 3 and B is a set which has elements, let's say A, B, C, D. So how am I going to write my elements here? Those are going to be written in this format, and then this is my B set which has A, B, C and D. So this is my B set. Now Cartesian product means, which is represented as A cross B. A cross B means each and every element of A has been mapped to each and every element of B. This means A has been mapped with, one has been mapped with A, one has been mapped with B, one has been mapped with C, one has been mapped with D. Similarly, 2 with A, 2 with B, 2 with C and 2 with D. Similarly for 3 as well. So what are we going to get in our set? This would become 1 comma A. Now again, remember this thing, they are generally ordered pairs considered in this portion. So here they've mentioned it as well. It is ordered pairs. So do not confuse yourself. 1 comma A and A comma 1 are going to be two different things. So this would be 1 comma A, 1 comma B, 1 comma C, 1 comma D. Then I would have 2 comma A, 2 comma B, and this would go on up till we have 2 comma D. Similarly for 3 comma A, we would have up till 3 comma D. So this is my A cross B set. This is how we represent our Cartesian product. Now from here what you can see, how many elements were there in A? N of A was 3 and N of B was 4. Now how many elements do we have in our Cartesian product? There are 4 into 3. They are basically 12 elements. So N of A cross B is equals to 12, which is nothing but 3 into 4, which is N of A into N of B. So keep this thing in mind. Number of elements in your Cartesian product, is equals to number of elements of A into number of elements of B. Now if I was to do the reversal, let's say if I was to find out B cross A, would B cross A be same? No, it is not going to be same as A cross B, because when we do B cross A, what are the elements that we are going to have? We are going to have A comma 1, A comma 2, A comma 3, B comma 1, B comma 2, B comma 3. Now here we are considering ordered pairs. Although if let's say we would be considering unordered pairs, then we could have said that these two would have been same. However, in Cartesian product, always we consider ordered pairs in our question. So that is why B cross A can never be equal to A cross B. So again, the same example has been shown here. A is 1 comma 2, B is xy. A cross B would simply be 1 comma x, 1 comma y, then 2 comma x, 2 comma y. This means every element of A has been mapped to every element of B. So again, now a few properties of Cartesian product. Given two non-empty sets A and B, A cross B, pool of all possible ordered pairs. So of course it is going to be each and every element that has been mapped, and A cross B is not equal to B cross A, important point, and N of A cross B is equals to P into Q, where P is elements in set A and Q is elements in set B. So it is P into Q. Properties non-commutative, as we seen, unless we have A equals to B. Now if A is equals to B, then of course our ordered pairs would simply become similar. So we cannot say whether they are ordered or unordered. That is why our Cartesian product would also become similar. Now if A or B, either of them is an empty set, then Cartesian product would also be an empty set, because we cannot map anything, right? Either if A is an empty set, then there is no element for us to map with. If our B is an empty set, then we do not know where are we going to map our elements of say set A. So it becomes phi. Cardinality of Cartesian product, again, if number of elements in A is m, number of elements in B is n, then number of elements in A cross B would become m into n. Again, the same things are repeated again and again. Now, this is an important result for you to remember. If let's say A is a subset of B, A is a subset of B, and we are trying to find out A cross C, then A cross C would also be a subset of B cross C, because I hope you are understanding, if all elements of A are present in all elements of B, that means the mapping is also going to be same for those elements which are in A. B would have definitely a few more extra mapping elements. However, it can be considered to be a subset. So this is an important point. Keep this in mind. Again, a few more distributive properties and all those things. A cross B union C can be simply written as A cross B union A cross C. So the distributive property basically works here. This is our distributive property. And again, those same things have been repeated again and again. So I hope you must have understood what exactly Cartesian product is. Now, based on this Cartesian product, we are going to find out our relation.